quick raise of hands, how many of you know what a lightning talk means? That's many, and which is a good thing. But I'll still explain what it means. Lightning talks are very short, very small talks, maybe 3 to 5 minutes, where we have wonderful speakers who will share something about something. Over here, something can be very vague. It can be beers or your experience in Prague, or how you got started with Python, about an event you're organizing, and so on and so forth. And that makes it even better because you never know what to expect. And we have very cool speakers, and a very star thing to say is that we would love to see more first-time speakers because we try to maintain a 50-50 balance between first-time and experienced people so that we can have a good share of topics to discuss and have fun, mainly. So now I would like to invite our first speaker, Sebastien, who will be talking about lightning talks.
Hello. How does this work? I don't know how to get this on the screen. Do I need to present or share?
Does anyone want to submit a talk proposal about technical difficulties during conferences? We still have the form open till noon tomorrow. If you don't have any ideas, you just got one. And if you have any other ideas, please feel free. The form should be available on Discord. How many of you are there on Discord already? We can have more. Come on. Okay, Discord is a wonderful place. Awesome. To talk to other attendees, sponsors, get main announcements. We also posted an announcement about the lightning talks a few hours back. And tomorrow you should have the same thing. And the technical difficulties are solved.
How do I get my slides up there? Oui. Cool. I got it. Woo. Right, my talk is on lessons for a lightning talk. Essentially, and I'll try to blaze through this, I'm going to criticize this guy, and that's fine because that guy's me, and that's me giving my first lightning talk at PyCon in the UK in 2023. Some of you were there. I know Tibbs was clapping for me there. So is Mark. So this is me criticizing myself. I'm not inviting criticism from any of you. I only receive loving feedback. So conferences generally look like this. This is everyone Pac-Manning all over the place. And then there's me. I'm the ghost trying to avoid the Pac-Mans because I'm nervous and afraid on the inside. The secret, instead of introducing yourself to one person at a time, introduce yourself to 700 people at once. So that's what I'm doing right now. I'm introducing myself to you, and that is the topic of my lightning talk. Why give a lightning talk? Because not everyone can go from zero to keynote. Learn by getting uncomfortable. I'm very uncomfortable right now. And also share to get feedback. Sharing is really the only way to get feedback. If you're not sharing, you're not going to get anything back from it. This is from feedback to myself from that last lightning talk. Don't be dense. You only have time to introduce your topic. Forget the details. Last time I had 5 bullet points. I spoke through 1. Show some cool stuff. I made mine super. Some other cool thing. This is done in Python, but then it uses Rust bindings, so I can compile it into WASM. So shout out to the WASM boys who gave a talk earlier. You can actually pull this up in a browser and start playing against the chess AI. It also uses bit masks, which is pretty cool. Great talking points. So Mark Shannon, he's over there. He said to me 4 words, make it do less. And I wrote about 1,000 words on that after that inspiration. A lot of this is on how to make performant Python or performant code. Another talking point, take yourself out the labor market. I took a sabbatical last year. I went to Japan, lived there for 2 months. It was great. If anyone wants any tips, I'm here till Saturday. This was feedback from my last talk. Someone asked me, they wanted to talk to me, but they couldn't find me. I only saw that 2 years later. So if you are looking to find me, I am this cat on GitHub, and that's a link to my profile. So yeah, don't try to talk to me on Discord. Thank you.
Our next speaker is Lumír, and he's going to talk about how to say no more easily, which will help plenty of us here. Good.
Do you think we'll have technical difficulties?
No.
How many for a yes? Whoa, okay.
Awesome.
So it was a
Hello.
no, as the title says.
All right, hello everybody. My name is Lumír, and today I'm going to talk to you about how to say no more easily, because there are plenty of opportunities out there, right? So if you listen to the keynote, you might want to become a core developer, or if you attended one of the talks, you might want to refactor your code, and so on and so forth, but the days is not going to be any longer. So you might choose your own things and battles, and you might want to say no more often. So how to do that? Rule number 1 is to 24 hours rule. And if you want to say no right away, if you ask something, feel free to do it immediately. But if you want to say yes on an opportunity, take at least 24 hours to think about it. And I'll tell you what to fill those 24 hours with. So rule number 2 is estimate. But the estimations are highly inaccurate. So I will give you 2 ways how to do it. First one is to estimate the required time, energy, cost, whatever you prefer, and then multiply it by 4. So you can, go up to a more reasonable number. Or another approach to this is prepare an optimistic estimate, prepare a pessimistic one, and sum them up. Then you can have roughly the number you are looking for. Then think about your future you. That's third rule. Future you is going to be as busy as you are today, even if your calendar is empty right now. So if you had the same opportunity as you are presented in 2 months, let's say, if the same opportunity comes to you in 2 days, would you be willing to take it? I would say that there might be a difference. So your calendar is not catching everything you do, and your future you is going to be busy as you are today. There is always an opportunity cost, so the days are not going to be any longer. And so if you want to add something to your plate, if you want to add something to your plan, you should do a deliberate decision to remove something else. And if you need help with that, I have my own dog for that. Go to your dog or your kids or your spouse, wife, girlfriend, boyfriend, whatever, and say, we can't go for a walk because I accepted the opportunity. And the ice will make it easier for you to say no. And the last thing is the honor to be asked, because sometimes, somebody approaches you, hey, I have this awesome project, and you are the best candidate to work, and then you are really tempted to say, yes, I'm going to help you, because why not? I am the best one to work on that, right? It's a trap. Don't feel the pressure to say yes just because someone thinks that you are the best candidate to do the job. You can be honored and still say no and find, for example, another candidate. That's it. Thank you.
Thank you very much for that talk. Now we have Tom speaking about from Paint to Python. Show of hands who think there will be a technical difficulty. That's optimistic. And you're right. Thank you.
Hello, everybody. I created this lightning talk last night because I really wanted to do one because it's my 3rd EuroPython and I haven't done one yet. I just said that. Connect with me on LinkedIn. That's my QR code for my LinkedIn. If you want a colorful QR code, it's really easy to do in Python. You can make one just like that. I'm going to share with you my journey. It's a 5-year journey. It started in 2020. I was a painter and decorator for 12 years, and then I decided I quite liked the idea of learning to code and data analytics. So I did A-levels, I did an apprenticeship, which I've just finished now. And if anybody else has an unusual career change, then come talk to me, because I'd really like to hear about it. I now work at Skanska UK, which is a global construction and development company. Everybody's always puzzled about construction. They are like, what do you do with data and Python in construction? But it's actually super data rich. It's maybe it's data immature and it's tech immature, but that means there's loads of opportunities, and there is all sorts of data going on, from IoT streaming data on all of the construction equipment to tons of unstructured data, which is great for AI and all of the sort of RAG and other solutions that are coming along now. That's a really corporate picture of me at my job. Skanska are active in Prague as well as the UK. So the top left is a bridge that Skanska built in Prague. The bottom is a huge office complex built in Prague. The top right is for the Americans. That's the Oculus building in New York, also built by Skanska. I wanted to have some fun, so I was celebrating my 10-year wedding anniversary, and I decided to create a chatbot because I didn't have enough to do, obviously. And it would send out kind of memories, information for the group. There was about 40 people, so it would send the map pins of where we were meeting and the timings of everything. So it was pretty handy. I deployed it onto like a home-build PC that I used as a server. I used Green API. If you Google that, there's loads of instructions on how to do this. That was the data that I structured about the messages that to send. That's just an example. It was actually a JSON file, but it has the location, potentially an image name, and then the text. This is a function I wrote to send the messages. It's pretty simple. But then I started to enjoy what I was doing more than organizing the anniversary event. So I got really distracted and decided that people are always trying to find me because I'm going climbing and I'm traveling around and doing stuff. And I always forget to share my location on WhatsApp so they can find me. So I was thinking it would be cool if people could just ask, where's Tom? And get my location. So I installed another app to track my location, deployed another server, so now there's 3 servers. And anybody, because I didn't restrict this to people I know, if they message me, and they say, where's Tom, they will get back my live location and a load of other information. Yeah, speed as well. So this all comes from the mobile device. So here I was walking at 6 kilometers an hour, which is like quite impressive, I think. Thank you very much. Those are the resources.
Our next speaker is Nora, who's going to be talking about Pynocchia, Tales of Floating Off by Just a Bit. And I have dad jokes sponsored by Judy, so don't blame me if you don't laugh. The future, the present, and the past walked into a bar. Things got a little tense. Thanks, Judy.
Nothing's happening.
Because it's the other way around. You want to swap.
Yeah. How do I? Yeah, okay. Where's the? Okay, there you go. Oh. Thanks. Why do I do that? I can also just. Okay, wait.
Yeah, exactly.
Yeah, that's fine. Hi there. What a sight to see. I'm Nora, presenting nervously. I'm not one for crowds, that is true. I'd rather code than face this view. But I made a vow I couldn't duck, so here I am, well, wish me luck. A colleague dared me, so I commit to rhyme my way through every bit. I chose a tale both weird and slick of floats in Python. Fast, not thick. And Pynocchia, our lead today, will show how floats can go astray. She went for toys in Dataland and had some change clutched in her hand. 3 coins of copper stacked up high, but Python floats, they tell a lie. It's 30 cents, she said with glee, but truth be told, it's 0, lots of zeros, 0.3, lots of zeros, 4. You see? Pynocchia grinned, this feels just right. She typed and ran her code in spite. 3 tenths by 1, what will it be? The screen said less than 3, not 3. Then rounding came, behold my feet. She cheered, 268, so neat. But eyebrows rose throughout the hall. That's 67, wrong and all. The crowd just frowned, but she stood tall. Float math is fast, can't win 'em all. Let's call her out and seek precision with 19-digit supervision. Unmask, the fib is clear to see, a tale of false equality. The truth she tells is not malicious, just binary math, precise yet vicious. Base 10 and 2 don't quite align, so floats misstep from time to time. In binary, some numbers loop, so Python rounds, they just don't group. It's IEEE that wrote the code, a standard all the big ones load. Not just in Python floats go wrong, Java, C, Go, all play along. Then one bright day, she gave a shout, I found a float that checks right out. 0.1 times 1.2, you see, returns 0.12 perfectly. The crowd just laughed and shook their heads. You fooled us once, the people said. So Pynocchia, sad and stressed, proclaimed the news is close. That's best. Bring out the sage, precise and neat, who stores each part in clear repeat. Assign some digits, then a power, no base to fudge, no hidden flower. Or count with fractions, plain and pure, where truth and math can both endure. With numerator and bottom part, fractions keep math sharp and smart. Pynocchia cried, I've got the fix. I'll swap in fractions, clever tricks. Or decimals, yes, that's the key. No more float lies, just honestly. But floats, once cast, still bring their sting, so tell the truth, just pass a string. Our floaty friend does have a role. For speeds and frame rates, it's on patrol. It shines and feels both vast and bright in graphics, AI, and data insight. From pixel shaders to learning weights, the speed unlocks performance gates. And now at last we end our tale with moral bright and warning pale. So when you see a float mislead, recall this puppet's fibbly deed. Use decimals for counting cash, use fractions when precisions flash, but if you float, then float with care and test your code before you declare. And now, dear folks, the tail rips tight. Thanks for joining this floaty flight. I'm Nora, that was my send. Thanks for the laughs, this is the end.
That was so cool. And now we have Ilja talking about if it walks like a duck and talks like a duck, it might be a snake. Show of hands for technical difficulties. Okay. Oh, cool. Whenever I ask, there are no technical difficulties. I think it's a me problem.
You should do it more often.
Sure.
Okay, cool, works. So, hi, yeah. As introduced, I will be talking about ducks and snakes. So this will be a fairly silly talk, but I hope you'll have some fun.
What?
Just a few quick words. My name's Ilja. I'm a software engineer at Infusion. We do lots of cool medical imaging stuff. This is not what I'm going to be talking about today, but we have an open room tomorrow at 3. So come us if you want to chat about that. Now, on to our main story. So I want to talk about a weird, quirky feature of Python. But for that, let me tell you a story about the duck. So here we have our main protagonist of the story. It's a very simple duck, as you see. And as you expect, it can walk and talk, and everything's fine. But then Here, we just do a bit of extra stuff. It's not important. But then, oh no, a radioactive Python appears. And it uses byte. But our duck gets away safely. That was a shock. But the duck is safe. Everything's fine. We can keep on walking and talking. Wait. What? So some of you might be thinking, ha, I know exactly what happened. You just assigned some attributes that overrode the methods. But that's not the case. And if we check this, it's still a duck. And if we check the ID that we stored before, it's also still the same thing. So what happened here? That's the mystery we're going to solve. And what actually happened here is, this is the function that was running before, and there's only one relevant bit, which is this function. We're going to take a look. Whoops, messed it up. We're going to take a look at it. This is the contents of the functions. Ignore this bit up here. Can you actually see? Yep. That's just declaring a type dynamically, whatever. The weird part is this. In Python, you can actually change the type of an instance that already exists. Why am I showing you this? Well, first, what can we do with our duck now? Well, not pretty much. We can put it into cryosleep and hope that the scientists figure out a way to cure it at some point. So here's a small library that I wrote at some point as a hobby. Effectively, it freezes things in place, and then they are immutable, and you cannot do anything to them. And for this library, I actually used this trick. So my question here is, why would anyone ever use this feature? And please tell me your use case if you have one. Thank you very much. The presentation slides are on GitHub.
And now we have the last lightning talk of the day by Stanley. Again, a show of hands of who think there'll be technical difficulties, because it seems like there are none when I ask about it. We had only one vote. Let's see. Take your time, it's okay. And do you have more jokes?
I do have
We have more jokes.
So, what's green, fuzzy, and would kill you if it fell out of a tree? A pool table. Tough crowd? No, I can see there's a lot of thinking going on, so that's good. I still have another one.
I'm not sure.
Okay. Are you good? Okay. Why do Swedish warships have barcodes? So they can Scandinavian.
Sorry for that. Hello, everyone. So, a while back, I was playing an ARG, essentially an alternate reality game, so kind of like an internet scavenger hunt. And I had gone through a bunch of processes. I had moved between a game executable, some docs, spectrogram, so on and so forth. And eventually, I got to a YouTube link. The YouTube link was entirely blank and only played a sound, which I found really jarring. Okay, you can't hear it, but honestly, that might be a positive. It's quite ear-grating. It looks somewhat like this on a spectrogram, and about 3 hours later, I would manage to convert it into this image. So this is SSTV. SSTV, also known as slow-scan television or narrowband television, in essence, is a method of turning sound into images, or vice versa. It is typically categorized by the fact that it takes really long to do, is pretty low resolution, however, is actually quite good for distances. It was mainly used in the 60s and 70s, and in this vein was actually used to send pictures of the moon landing from, well, the moon. More modern uses are like for hobbyist radios, so like amateurists sending pictures in between each other, and as previously mentioned, ARGs. To more explain how it works, I will be talking about PD120, which is the type that I worked with. And overall, all SSTV signals start with this VIS indicator, shown here in the green, essentially telling our decoder that an SSTV signal is starting and that this is where the data will be stored. So there's also this red section, and this encodes for the specific type. So PD120 has this binary with 1100 hertz being the ones and 1300 hertz being the zeros. After we get through our VIS code, we can go to the actual lines. PD120 encodes 2 lines per pulse. We start with this yellow part, which is the sync of 1200 hertz for a short segment, essentially telling us the line is starting. Then luminosity of the first line, our red shift, blue shift, and then our second luminosity. Oh, my bad. So essentially, while we only have one color component here, that is actually because the color component is the average of both of them, and it's much, much faster and isn't really visible. So how do we get this in Python? If we use the pedalboard library, and specifically the audiophile class, we can return an array like this, essentially an array of amplitudes of the sound. So amplitudes aren't what we need. We need frequency. And sound is a wave, and amplitude is how far that wave is from its equilibrium position. We can calculate frequency by getting zero crossings, essentially moments where the amplitude changes sign. After we have gotten such, we can actually calculate our image. We can show it. First, all we have to do is get the line starts, so the sync points that I mentioned previously, and we just do this by calculating a quote-unquote streak, so how many points in a row have that frequency of 1200 hertz or around, and then once it's long enough, then we add that to an array, marking where they are. After this, we can actually draw our image. As seen in the code here, we mark the starts of all 4 components, which we know because SSTV is a commonly used format. And then for every single pixel in a line, or in our case 2 lines, we calculate the image and add it to a 3D array. 2 axes for, well, the 2 axes, and then the third one for RGB, using a conversion function to change from YCRCB to RGB. This returns an image like this. And if you used a professional program to transport SSTV, like MMSSTV, you'd get an image like this. So if you look at the left side here with the green lines that kind of slant the image, this is for one particular reason. So this signal and this image is actually sent from the ISS, and images like this are still commonly sent by the ISS. So as the ISS gets further away or closer, the Doppler effect happens, and this is while it was getting further. The frequencies get lengthened, and thus it goes off-center further and further. Now you may notice that our image does not have this. This is because we mark the points where sync starts instead of marking the times, and that leads to a more clear image, despite the fact that there are wiggles. But that wiggles more come from the zero crossings rather than the image quality itself. Thank you.
The lightning talks were great, and that's it for today. So lightning talks will be back tomorrow, and so will everything else. We'll still have 2 keynotes.